Okay, this is the P3 paper from June 2021. It's question number 3. This is an integration question. We're going to be using the reverse chain rule for that bit there. And then we're going to do a little bit of algebraic long division to get this in the right format. And then it will just be a standard integral once we get that far. Okay, so let's have a look at 3 part 1 first of all then, which says we want the integral of 12 over 2x minus 1 all squared dx. So when we're looking at the reverse chain rule, what we need to be aware of then is that we'll have functions such as this one, which can be rewritten as 12 2x minus 1 to the minus 2 dx. Once I've written that, then what I've got is fx here, in this case 2x minus 1. I've got the differential, the differential of fx multiplied by it, because the differential of 2x minus 1 is 2. Any constant would be a multiple of that. And then I've actually got this as being g fx. It's not fx itself, but it's some function of fx, in this case g being the function to the power of minus 2. And if we do have it in that format, then we know we can use the reverse chain rule on it. So let's actually go ahead and do that then. That once I realize it is the reverse chain rule, I try and guess what I think the function is going to be that differentiated to make 2x minus 1 to the minus 2. Well, the only possibility for that is that I had 2x minus 1 to the minus 1. Let's go ahead and actually differentiate that. So I get dy by dx is minus 1, 2x minus 1 to the minus 2, multiplied by the differential of what's in here. So multiplied by 2, or in other words, minus 2, 2x minus 1 to the minus 2. So what we can see here is that the integral of minus 2, 2x minus 1 to the minus 2 makes 2x minus 1 to the minus 1. I haven't got that. What have I got? I've got here minus 6 lots of that. Okay, I've got the equivalent of minus 6 lots of that. So that means that when I'm doing the integral of 12 2x minus 1 to the minus 2 dx, it's minus 6 lots of 2x minus 1 to the minus 1. And then don't forget to have your constant on there. You can always go ahead and now actually try and see if that works. If you do differentiate that, I haven't got time to do that here, but it works out to be the answer that we're looking for. A lot of practice needed at those reverse chain rule. Go back and look at some of the other questions that I've got on the channel and see other explanations for different types of questions. Okay, that's 1. So 2 part A. 2 part A says, can we write 4x plus 3 over x plus 2 in the format a plus bx over 2. A plus b, over x plus 2. And the simplest way to do that is to do the algebraic long division. Okay, so we're saying 4x plus 3. How many times does x plus 2 go into 4x plus 3? So when we're doing those, we say how many times does x go into 4x? X goes into 4x 4 times, and we now do 4 multiplied by all of that, which is going to give me 4x plus 8, and then we simply subtract 4x plus 8 from 4x plus 3. When we subtract it, the whole point is that that bit will cancel. 3 minus 8 will give me minus 5, So that's my remainder. So I can now write 4x plus 3 over x plus 2 is my 4 here, but then with 5 left as a remainder out of x plus 2. So I've now got that in the format that I wanted. So that's the answer for part A. And then part B says, can I integrate that? Or rather, can I integrate that? Yes, I can. Let's go ahead and have a go at doing that. So we're going to say the integral, it's got limits between -5 and -8 of 4x plus 3 over x plus 2 dx. So the first thing we're going to say is that's the same as the integral between -5 and -8 of 4 minus 5 over x plus 2 dx. Okay, so when we're integrating this then, the integral of 4 is no problem. It's 4x, and hopefully you can recognise 1 over x. I know it's 5 over x plus 2, but 1 over x is the type of function, and that's a log. So if I'm doing that, 1 over x plus 2 would give me log x plus 2 minus 5 lots of that is going to give me that between -5 and -8. And those two really help me to remember that when we're doing this, as I haven't put it in yet, it's the modulus of that thing there. That takes account of the fact I don't want a log of a negative to come out with this. Well, I'm not going to get the log of a negative because the -5 and the -8, doesn't matter what they work out to be, I'll just ignore them and take the modulus of that. So subbing that in then, first one, 4 lots of -5 is -20. -5 lots of log, let's just do it slowly, -5 plus 2. Sorry, again, with the modulus sign. That's the first term. Minus, sticking the -8 in is going to give me -32 -5 log the -6 here. And again, that's the whole point about having that modulus sign in there. This is going to work out to be, well, if I just concentrate on the numbers first of all, -20 minus -32 is 12. And then I've got plus 5 log 6 minus 5 log 3. So I've just swapped those two over in terms of the fact that this one was a minus here and this one would have worked out to be a plus there. So I've just tidied those two up to make it a little bit easier for me to now say that's 12 plus, you can take 5 out at the moment, log 6 minus log 3, just because that's then 12 plus 5. Log 6 minus log 3 is going to be log 2 here. And then if we go back, what does it say in the question? Find the exact value. That is the exact value. And in its simplest form, yeah, I can't think of anything simpler than that in terms of the way to write that down as an answer. So hopefully that one all makes sense.